Alright, in this problem, number 3, in Chapter 3 of Garrett Biochemistry, we'll be calculating delta G from delta G naught prime, the standard free energy of hydrolysis of acetyl phosphate. Delta G naught prime is equal to negative 42.3 kilojoules per mole. And we are given the equation acetyl phosphate plus water yields acetate plus inorganic phosphate. So we're supposed to calculate the free energy change for acetyl phosphate hydrolysis in a solution of 2 millimolar acetate, 2 millimolar phosphate, and 3 nanomolar acetyl phosphate. Equation 3.8 in your book is as follows. The free energy change for non-standard state concentrations is given by delta G is equal to delta G naught plus RT ln of products over reactants. And so remember, delta G naught prime is the same as delta G naught, except that we're given 1 times 10 to the minus 7 for the hydrogen ion concentration under delta G naught prime standard conditions. But that's not relevant here, so we can just plug in delta G naught prime for delta G naught. Right, so let's go ahead and get started. Okay, so we have this equation where acetyl phosphate plus water, and this is a reversible reaction, yields acetate plus inorganic phosphate. Okay, and we know that the delta G naught prime for this reaction is equal to negative 42.3, and we're given in kilojoules per mole. Okay, so keep your units straight here. Alright, so we can write this equation. This was from the chapter. Delta G is equal to delta G naught prime plus RT ln of products over reactants, which in this case would be acetate inorganic phosphate concentration over acetyl phosphate. And we don't care about the water because it's a liquid, so it's not going to factor in here. Alright, and so we know from this equation, let me just change colors here because I wrote this kind of close together. Our acetyl phosphate concentration at the beginning is 3 nanomolar, and then we don't care about the water. The acetate concentration is 2 millimolar, and the inorganic phosphate is it's supposed to be millimolar, isn't it? I think I've written it down wrong here. Yeah, 2 millimolar. Okay, so, and I believe that was 2.0. Let's look at our problem again. No, we weren't given any decimal places here. So 2 millimolar and 2 millimolar. Alright, so let's go ahead, and this is just a plug in the blank problem. So let's go ahead and plug in. Alright, so delta G is equal to delta G naught, which is 42.3 kilojoules per mole. So this is in kilojoules per mole. So remember, our gas law constant is 8.314 joules per mole Kelvin. And so if we want to convert that to kilojoules, we need to say 1,000 joules is 1 kilojoule. Okay, so that gives us 8.314 times 10 to the minus third kilojoules per mole Kelvin. So I'm going to go ahead and use that for our gas law constant. So that's 8.314 times 10 to the minus third kilojoules per mole Kelvin. And I've written this kind of close together, so I'm going to go ahead and erase it. Okay. Alright, so, and then we have times the temperature. Now the temperature is the tricky part here because we weren't given a temperature. If you look at this problem, we were not given a temperature, and that is a little bit irritating. So the book actually says, well, we're just going to choose 20 degrees C because 20 degrees C would be a good choice because that's, good round number. Or we could use 25 because that's generally our standard state conditions. But at delta G naught, we should be using 37 because that's going to be body temperature. So really, I think this problem should be done at a temperature of 37 degrees C. But since your study guide is using 20, I'm assuming that your answer guide in Cengage is going to also be using 20. So we're going to be using 20 degrees C plus 273 gives us 293 Kelvin. Okay, so we're using 20 degrees C because that's what the study guide is using. I really think we should be using 37 because this is delta G naught prime, and that's going to be under biological conditions. So, but we're going to use what the study guide is using, so that's 20 degrees C. Okay, so then we have ln of 2 times 10 to the minus third times 2 times 10 to the minus third, okay, divided by 3 times 10 to the minus ninth. Okay, so let's make that a little clearer. So we have the ln of this. Okay. All right, so if we calculate this product, let me get a different color here. If we calculate this right here, 2 times 10 to the minus third squared divided by 3 times 10 to the minus ninth, we get 1333. Okay, so how to work that out? I'm taking the ln of 1333, multiply that times 293, multiply that answer times 8.314 times 10 to the minus third, and we get delta G is equal to this is a negative 42.3. Negative 42.3 kilojoules per mole plus 17.5, and this was in kilojoules per mole, so we can add those guys together. So we get delta G is equal to negative 24.8 kilojoules per mole. Okay, and that means that this reaction will proceed in the forward direction.